Hey everybody, my name is Alex with Hake Hardware, and in this video we are going to go over how to get a autonomous farmer cluster working in Windows 11 using the advanced CLI. Now this video is going to be a little bit long because we're going to be setting up each of the cluster components, and sometimes, the first time going through this, it can seem a little overwhelming, but really the steps are pretty easy. We're going to be using PowerShell scripts to keep things organized. And overall, I think it's a pretty simple process once you go through it initially. All right, so I have the wiki. I am in the Autonomous Windows CLI, and then Farmer wiki here. And I'm just going to collapse this bar to give us a little bit more space. And let's just jump into the prerequisites. So you should already have your node running, and I've got mine up right here. And you should have prepared your disks. You can do it either through the GUI or the CLI, depending on what method you prefer. So if I open up my File Explorer here and I go to this PC, I can see I have my two farm drives here. You should have NATS running as a service. So if I go to Services, here we go, Services, I can find NATS, and it is running. And then just always, it's a good idea to check the official wiki if you need to see like some system requirements or you want to reference something there. If you're going to be using your GPU, make sure you have at least drivers 550 or newer. There's some plotting requirements here. And then here's the official wiki for clusters, which is pretty good, but they don't give you, as in-depth of instructions, but there is some additional information here, such as, being able to run multiple, like a cache and a plotter in the same command. We're actually running them all separately, which I prefer. That way they each get their own logs. So let's just talk quickly about a cluster. There's four components. You have the controller, that's like the brains of the operation, the cache, which stores the piece cache bin, and the cache is used by the plotter for plotting. So typically this piece cache is split up. Like if you were to run a non-cluster farmer, this would be split between all of the farm disks. So it's actually 1% by default of the farm disk. So you do lose a little bit of your space on your farm disks. With a cluster, you can specify a specific folder that you want to put that in, so you can store it on your OS drive. Or if you have like a secondary drive that you just want to store it on, it can be a hard drive, but honestly, I recommend just using an SSD for everything. And then the plotter is going to actually do the plotting, and the farmer is going to do the farming. And all four of these can be run, basically one or all of them, on multiple hosts. So if you have one computer that you want to use as the plotter, you could run a controller, cache, and plotter on that, and then just run the farmer on another host where you have all of your disks. And you can mix and match and move things around. There are some optimizations as far as network usage, because the plotter, if you have a modern GPU, will actually use up quite a bit of bandwidth sending data to the farmer and getting data from the cache. So just keep that in mind, and we'll cover it slightly. But if you're noticing slow plotting, there could be a number of reasons, but one of them could be that your network is saturated. So there's a lot of benefits of a cluster, mainly the division of responsibilities allows for redundancy, it allows for distributed compute, it allows for a lot of different things, and it goes into a little bit more depth in the official cluster wiki if you want to go and read through that. The main downside that I've noticed is just a little bit more complexity. So if you only have a single host, sometimes it's easiest, honestly, just to run Space Acres, which is the graphical user interface for Autonomys, or just run a node and a farmer. But as soon as you start getting a lot of space, and honestly, even for people with a single host, if you have a lot of disk space, I prefer to run a cluster. So you probably have seen this when we went through setting up the node, but we want to make sure we have this Autonomys folder created and a subfolder for the cluster, and then a subfolder in the cluster folder for the controller and the cache. and we'll be storing controller data here, which is it's not a lot of space. And then as you heard me mention before, we're going to put the piece cache.bin in this cache folder. And the cache size grows over time, but you will be specifying like a maximum size for the cache. So if you only have, let's say 10 gigabytes that you want to dedicate to the cache, then you can specify that. But keep in mind, if your cache is too small, it might slow down plotting. All right, let's get into our folder here and let's go to the Autonomys folder. And I created a farmer before for the farmer guide, but now we're going to be doing cluster. So you don't need that farmer folder if you're just going straight to creating a cluster. But do keep in mind, if you are converting from a farmer to a cluster, you need to go into your drives here. There will be a piece cache.bin in here. You need to delete it because it's not going to be used anymore, because the piece cache will now be stored in the cache folder that we create in our cluster folder. So let's actually create the controller now, and then the cache. Okay. And for the cache drive, let's say you have, another disk that you want to store it into. You can store the cache on like a separate disk or a folder in another disk that you have space. You don't have to put it on your operating system drive, but for this guide, we're just going to keep it simple, and I'm going to be creating a 10 gig cache on my OS drive. All right, let's download the executable. The cluster is going to just be using the farmer executable for all of the components. So we'll go over to the GitHub page. On the right-hand side, we have the releases. We're always going to want to make sure we get the latest. And as far as which version you're going to get, make sure you read through the two versions that are here. There's a V2 and there's also a Skylake. And then you can see the dash ROCM is for AMD GPUs. I think it's still maybe experimental. I'm not totally sure. And then, like I said, we're going to make sure we get the farmer. And I have an NVIDIA. Actually, I don't even have a G. We're going to be doing CPU plotting, but it's the same. CPU plotting will be automatically disabled if you have a GPU that's compatible and you have the latest drivers. So drivers 550 or higher. But I know that I am going to want the Farmer Windows Skylake. So I'm going to go ahead and download that. Most people, you're going to be using the Skylake unless you have a GPU or an AMD GPU, and then you might use the ROCM. V2 is for older CPUs. So let's open up our folder here, and we're just going to cut and then go to our Autonomys folder, cluster, and we're just going to paste it in the cluster folder. All right, back to our guide here. So we just need to make sure we know which disks we're going to be adding to our farm, because we're going to specify that in our farmer script. But we're going to start with the controller first, because that is the first thing that needs to be deployed. So to do that, we're going to open up Notepad. And I've got some stuff that I deleted out of here. Oops. Bring that back up. Okay. Sorry, I know it's going to be bright, so hopefully you're prepared for that. The first thing we're going to need to do after we open up Notepad is paste in the contents of one of these scripts below. So just like with the farmer and the node, there are local and remote possibilities. So if your controller, the thing that we're deploying right now, is on the same host as your node, you're going to select the local controller. If they're on separate hosts, then you're going to select the remote controller. I'm using a local controller. So we're going to open up this GitHub, and this is just a simple script here. We're going to copy that file, open up Notepad, and paste it in. And we're just going to, just like with the remote controller thing, if you have NATs running on a separate host, which is possible, you're going to want to put the IP address of the host where NATs is running. For the most part, you're just going to leave this as is because NATs will be running on your current computer. We haven't set up Prometheus yet, so you can just leave this. But in the future, if you want to use like Grafana and Prometheus to get metrics, and Prometheus is running on a different host, you'll have to put the IP address of Prometheus here. Now, if Prometheus is running on your local host, you can leave it as localhost. And then the base path is going to be your home, the directory that you're launching the script from, and then the controller folder. So since we have this in our cluster folder, it'll just be the controller that we're going to be putting the controller data in. And then this is just the command. You're going to want to make sure if there's a newer version, like let's say, November 20th or something, you're going to want to make sure that you update your exe file to match whatever the latest is that you downloaded. Everything else can basically be the same. It's going to output the logs to controller.log. You can update that if you want it to be a different name. And now we can save this file. So file, save as, and we're going to put controller.ps1, so that's a PowerShell script. Change text documents to all files, and then make sure you're in the cluster folder, and then save it. So if we go to the cluster folder here, we can see we now have the controller script in here. And if you haven't already, you need to make sure that you have remote signed for your execution policy. So if we go back to the node here real quick, we scroll down, you might get this error if you try and run a script without the set execution policy remote signed. So you might have to run this to set the execution policy in order to run your scripts. So just keep that in mind. All right, we are saving the script. So we just saved the script. And if you go to run the script and it just exits out and there's no errors and there's no log output, then you might need to install this Visual C++ redistributable. It's super small file, it's really quick. Just install it, reboot, and then pick up where you left off. All right, there's two ways to run this script. One is, I think I have two of these folders open. There we go. Okay, so one is you can right-click on it and just click, right-click on it and do run with PowerShell. Now that's going to open up a PowerShell window, a terminal, and try to run the script. But if the script has an error, it might print the error real quick, but then close the terminal, so you won't be able to view the error. And that can make it hard to diagnose things. You can check you should be able to check the logs to see what the error was, but it might not have logged the error. So another option is to find another place in this folder where there's no file, right click, and then do open in terminal. And then just type controller, and then hit tab. Actually, that didn't work out. You might have to actually type it all out. So controller.e or .ps1. There we go. Okay. And then you can just hit enter, and then that'll start your controller in the terminal. So that's typically what I do. And I even do it another way because I like to put all of my components in tabs in my terminal here. So you'll see I'll do it another way for when we deploy the cache. All right, so back to our wiki guide here. We just saw us launch, and once it launches, it's just going to basically wait for the rest of the components. So there's not a whole lot going on right now in our controller, it's just waiting. So let's move on to the cluster cache. So as mentioned, the piece cache bin is stored in the cluster cache, and when you connect it to your cluster, the cache is going to be identified, and then it'll start syncing the piece cache. And there's a forum post here that goes in depth into exactly like kind of how the piece cache works and why it's important and how it could affect plotting. So let's click this link to get the cluster cache script. We'll copy that. We'll open up Notepad here again, open up a new tab, paste it in, and it's going to be very similar where, again, if Nats is on a different host, you're going to want to update that. If you're running Prometheus on a different host, you'll want to update that. We have the directory that the script is launching from, and then the cache folder, so that's where the piece cache will get stored. And then if you want your cache size to be different, then you can update it here. Right now for Mainnet, we're very early, so the cache is actually much smaller than 10 gigabytes, but if you have more space, it's only going to use the space that it needs. So you could do like 100 gigabytes, and if the max cache size is only 2 gigabytes, it's only going to use those 2 gigabytes. So You can set it to, I typically like to set it to the maximum space I have available. I'm just doing the guide with this virtual machine, so I'm just going to keep it kind of small. But if you have like 200 gigabytes available, you might as well just use it all. Otherwise, for plotting, you may need to kind of babysit it and make it larger and larger as the cache grows. Now keep in mind this is setting the maximum size. So let's say like in a year, the piece cache is like 200 gigabytes and you keep it at 10. That's fine. It's just going to download only 10 gigabytes of the cache. And there might be some misses when plotting, and it'll have to download those pieces, which might slow plotting. But in a year, you might not have to replot too often. So the cache is most important when you're doing the initial plotting. And then again, you can change the log file if you want. And this is just the script with all the variables put in. So again, we're going to do the same process where we do save as. We'll do cache.ps1 this time, all files, and then make sure you're in the cluster, and then click save. And we can see we do have the controller logs here. So if I open up the controller logs, I can see the logs that the controller printed out. Let's minimize. And if we go into our controller folder, you can see we now have an identity.bin and a known addresses.bin. So we can see that our controller is storing the data in the controller folder. Now, just like with the cache, you could right click, or with the controller, you could right click and do run with PowerShell. But I like to keep everything in a terminal window. So I'm actually going to open a new terminal window. And I know that I want to cd, so change directory, into the Autonomys folder. And then I want to go into my cluster folder, and then I'll hit enter. And if I do dir, I can see that I have my cache.ps1 here. So I'm just going to put cache.ps1, and then I can run it right from here. And we can see it created a cache. And if we go over to our controller, which is on the left here, we can see a new cache was discovered. So it's discovered our cache, and the ID is the same as the ID that's printed here. Okay, so we can move on to our plotter. So the plotter and the farmer can basically be started in any order. And if you start the plotter, it's not going to start plotting until you connect the farmer. And if you start the farmer, it's not going to start plotting until you connect the plotter. So it's just kind of what came first, the chicken or the egg. Who knows what needs to be there first? But you can do it in any order. In the wiki, we're going to do the plotter first. So keep in mind with the plotter, if you have like another computer and you have two different hosts, the plotter is going to have to get data from the cache and then send data to the farmer. So if you do have 1G for your networking, or God forbid anything less than that, then you might run into issues where the plotter is saturating your network. So just keep an eye on your network usage if you're noticing slow GPU plotting. And if the GPU is detected, it will automatically disable your CPU. You don't want to be trying to plot with your CPU and GPU. It's not going to be any faster. All right, let's go to the cluster plotter script. We'll copy it like we usually do. We'll go into Notepad. We'll create a new tab here, and then we will paste it in. And this one's pretty simple. You don't actually really need to change anything except for ensuring that the .exe is the correct version, and then updating NATS or Prometheus if you need to. So we'll do File, Save As, and we will delete that out. And we're doing the plotter, so PS1, all files, and then we will just click, make sure we're in the cluster folder, and click Save. And just like with the cache, we're going to do a new tab here, and we'll do cd Autonomys cluster dir. We can see that our plotter.ps1 is there. So we're going to do plotter dot, and I'll just do tab to finish that. And we can see the plotter has started. Now you don't see anything about how my CPU is disabled because I'm not doing GPU plotting, but you'll probably see like CUDA devices equals, and there'll be like a 0 there. That's like your GPU's device 0. So if you see that, then you should have your GPU plotting for you. Now we're not really going to see anything in our controller, but you can see that the piece cache is starting to sync. So when I connected my cache, that piece cache sync started automatically. And if we go into our cluster and we look at our cache, we can see we have the piece cache is listed here. It's 10 gigabytes. So I mentioned before that it would only use what it needed, but it looks like it has reserved the full 10 gigabytes. I don't know if that's because the piece cache is larger or it might just use the full space you provide it. So just keep that in mind. All right, we'll close out of that. And the last thing we're going to do, let's go back to our browser. And we can close out of these GitHub links. And we're going to scroll down and go to the farmer. So again, we're going to click the farmer, copy, open up Notepad, new tab. Now here we're going to need to do a little bit more work because we need to put in our reward address, which let me grab that. So you're going to need to have a wallet and you're going to need to grab your reward address and you're going to paste it in there. And then just like before, make sure Nat's IP, Prometheus IP is correct. But we're going to need to update some paths because I don't know how many drives you have in advance, so I can't kind of template that out. I mean, I could, but it's not as easy as just making some modifications here. So if we go into this PC, I can see my two farmers. I have a Y and a Z drive, and I'm going to be plotting to this entire drive. So since I have two drives, I want to copy just this, what's in the quotes here, the path equals size equals Control C. I'm going to go to the end of the reward and click enter. And then I'm just going to space all the way and paste that in. And then you need a backtick. So for PowerShell, if you want to put a command on multiple lines, you need a backtick after each one. And now I can go in here and I know I have a Y drive and I have a Z drive. And I know I want 125 gigabytes for each one. So these are 128 gigabyte disks. So you can see it says 127, but it's basically 128. I think it rounds down or something. And I'm going to be doing 125. So you can see it leaves like 3.86. It says gigabytes, but it's not really gigabytes. I think it's specifying it in gigabytes. It's so confusing that they keep, like, everybody displays things differently. But just if you do it too large, you'll get an error. And if you do it too small, you can always come in and update your size and it'll automatically update when you restart your farmer. So honestly, it's sometimes best to go too small and then you can slowly increment it as needed. So I have this set up correctly. I've got my reward address in and my disks look good. So I should be able to just file save as farmer.ps1, all files, make sure I'm in my cluster, click save. Now we can close out of Notepad because we're done with that. We can close out of that. And then we're going to run the script. So let's go back to our terminal here. We'll do another tab for one more time, cd autonomous cluster, and then we're going to do farmer.ps1. So we can see it's going to do some checks, it's going to do some benchmarking, and then it'll detect the two disks. We'll give it a second here. Okay, so we've got our two disks were detected, and we can see it's picked up plotting where I left off when I was doing the farmer, but it's not going to plot anything really until this piece cache. So if we go all the way to the first one, the piece cache is still syncing. So you can see that it discovered those two disks that I just added. So the farms are discovered and they've been connected to the controller. The piece cache is going to continue to sync until it's 100%, and then you will likely see the plotter. So even though I've got this plot sector request and it looks like it's starting to plot, it's really not going to start plotting with speed until the piece cache is synced. So it could take a little while you're waiting for everything to sync and prepare, but give it a couple hours. I mean, sometimes it could take even longer, unfortunately, but it should start plotting. If you didn't get any errors in your logs, then it's probably fine. You can always check. If I right click here, go to Task Manager, you can check and see, like I can see that I'm downloading a lot of data right now, so my piece cache is being synced. So if you're seeing like a lot of activity, or sometimes your disks need to get initialized, and that requires like writing data across the entire space that you set for the farmer. So you might see like high disk usage. This is all normal. Just give it some time to work itself out. As long as you didn't get any errors in the logs, again, you're probably fine. As long as you have like a good amount of peers. So if I look at my node, I've only got 10 peers, but I am synced. If it says idle, it means you're synced. So it typically does. I haven't seen it mean anything else than that, but um, so as long as everything's looking good, just give it some time. Worst case, you can ask in the Discord, and you're probably okay though. All right, let's jump back to the guide here. So yes, each component's going to log to their own. So if we go to our folder here, cluster, we can see we have a cache, and this is the cache logs. And we have controller, farmer, and plotter logs. So each one has a log. And I suppose you could create a logs directory and change the output for the logs to the log directory so they're all kind of neatly in their own directory, but I don't mind it just how it is now. Updates and maintenance. So, okay, so let's see like a new version comes out. You're going to typically want to shut things down in reverse order in which you started them. So the plotter or the farmer you can shut down first, then the cache, then the controller. If you need to stop NATs, you can stop NATs. You typically don't have to. And then shut down your node, update your node, start your controller, start your cache, start your farmer and plotter. That's typically the best way. You're probably not going to hurt anything if you don't do it that way, but it's just, I don't know, maybe I just don't like to see errors in the logs, but you might see some errors in the logs if you shut it down in the wrong way. So that's it. At this point, you should be plotting, should be good to go. If you get any errors, join the Discord, either mine or the official Autonomys Discord, and you might be able to get some help. You can also there's a autonomous.xyz. If you go to About, there's a forum, and you can post your question on the forum as well. Typically, they prefer you post it in the forum, but you can also ask in the Discord. And that's it for setting up a cluster. Hopefully this was helpful. Please subscribe if you want to get notified about new Autonomys videos. I'm going to be doing an advanced cluster guide as well, and there's multiple ways you can run clusters because you can use Docker as well. This was the CLI. There's going to be a Docker, so we have CLI, Docker, and then I have a Space Acres guide. Some of my guides I'm deprecating out to go to newer, different guides. So if you see deprecated, there's probably going to be a link to the new guides here. So anyways, check out my wiki and subscribe, like this video, and I'll see you in the next one.